A 10-gram sample of nitrogen is at STP, which property increase when the sample is cooled to 72 K at standard pressure. So in this problem, we know that a 10-gram sample. Well, a 10-gram sample is going to be the same mass regardless of what temperature it's going to be at. So therefore, we can definitely eliminate the mass. We also know that when the temperature is cool, when the sample is cool, temperature cannot rise, okay? So it's asking which one is going to rise. So therefore, we know that temperature cannot rise. Now, this 10-gram sample of nitrogen is cool. And so the question is whether or not the volume is changing. Well, the volume is not changing. It's still within inside the same sample, okay? Now, the only possibility in this case is the density. As it cools, it will change its density and become a slightly little bit heavier. Consider in terms of when you're looking at water, in which the going from a liquid to going from a gas to a liquid, the density of a liquid is higher than the density of a gas. So the answer in this case will be the density. Which element is a gas at STP? So we want to know is which element here is a gas, okay? So first of all, S is a sulfur, so potentially maybe. K is a metal, so we know that can't be it. P is phosphate, could be, maybe not. Xe is a noble gas. That's noble gas. So therefore, at group 18, Xe has to be a gas. Okay, maybe 1, maybe 4, but we know for sure Xe has to be a gas. So therefore, Xe here is the only possible answer. A 5-gram sample of Fe solid is to be placed in 100 milliliter of HCl aqueous, which change will result in the fastest rate of reaction. So here our keyword is fastest rate of reaction. Okay, so let's read this. Increasing the surface area of Fe, so that means there's more chance for it to react. And increasing the concentration of HCl, that means increasing the amount of HCl. So if you increase the surface area and you increase the concentration, that definitely going to have to increase the rate of reaction. That's possible. Number 2, increasing the surface area of Fe. Okay, we agree. And decreasing the concentration. No, if you decrease the concentration, there's less for it to react. So we know that can't be it. Decreasing the surface area of Fe. Well, no. If you decrease the surface area, then you will have less to react with. And decreasing the surface area, again, that's not possible. So only possible answer here is increasing the surface area and increasing the concentration. Which process is commonly used to separate a mixture of ethanol and water? So here the key word here is separation. So this is a definition. So we know that titration here is a method in which we are going to neutralize an acyl base. So therefore, that cannot be a separation method. So we can eliminate that. We know that ethanol is a liquid and water is a liquid. Now, filtration is a method of separating a solid from a liquid. So that can't be neutralized. So we can eliminate that. Now we have left is ionization and distillation. Now, ionization is the process of making ions, and that's not what we're wanting. And distillation is the process of separating two liquids by boiling. Okay, that sounds right, and that will be your only possible answer. Number 15, a sample hydrogen gas will behave most like an ideal gas under the condition of what? So here in this case, we're looking for is a gas, an ideal gas. And remember, in an ideal gas, you want to think about the vacation on the beach. On the beach, it has high temperature and we have very little pressure. So we want a high temperature, low pressure. So therefore, low pressure, high temperature. The collision theory states that reaction is most likely to occur when the reacting particle collide with the proper what? This is the one where we watch about the girl and the guy colliding in the hallway, and we know that in order for a collision to happen, we must have enough energy, and that they must be in the proper orientation. Okay, so this is where we're talking about this. So in this case, we want to go like that. Okay, so therefore we're looking by energy and orientation. At STP, which sample contains the same number of molecules as 3 liters of H2. So at STP, that's standard temperature and pressure. And we know that we want to know which one has the same number of molecules. Well, if we have the same number of molecules, then we must have the same number of liter. Okay, disregarding what type of element it is. So what we want to do here is we want to concentrate and zero in on any one that has the 3.0 liter. And of these four, answer 3 has the 3.0 liter. Addition of a catalyst to a chemical reaction provides an alternative pathway that does what? Remember that we are talking about here is we are talking about a graph that looks something like this. So when we add a catalyst, what we want to do is we want to change so that we want this pathway. We want the pathway to become smaller, okay? So we want that pathway to become smaller. And so therefore we want to require less energy. So therefore, the only possible answer will be it decreases the activation energy, okay? A sample of water is boiling as heat is added at a constant rate. Which statement describes the potential energy and the average kinetic energy of the water molecule in the sample? Diagram. We can see that the boiling point is occurring right here. And at that point, this is temperature. So at that point, temperature is constant. Okay? When temperature is constant, average kinetic energy or kinetic energy must also be constant. So if average kinetic energy is constant and that heat is being added, it must go to somewhere. So it's going to the potential energy. So therefore, the correct answer is the potential energy will increase while the average kinetic energy remains the same. Entropy is a measure of what? This is a definition. Energy is a measure of disorder.